Hello everyone, it's Mrs. Heather, and today we're going to be going over Zeta Lesson 21 decimal remainders. So I'm going to hop into that because it's a pretty big lesson, but I would like to go ahead and review last week's, which is just dividing a decimal by a decimal. I'm just going to refresh it in your mind for a sec. So if I had 0.006 divided by 63.87. Just reviewing. What do we do first? Can we divide this into this? No, we need to move our decimal 1, 2, 3 spaces. We will go to this decimal, move it 1, 2, 3 spaces. Now this decimal ended where there should be one more place value. We put our 0 in. If you'd like, you can now go ahead and remove your hops. Alright, do we need these zeros in the front anymore? Nope, because 6 is our whole number. Okay, so now we have 6 into 63,870. Very doable. Let's go ahead. 1, 6 times 1 is 6. 0, we drop down our 3. How many 6's go into 3? 0 6's go into 3. It's not big enough, but we still need to put our 0 at the top. Minus 0 equals 3. We bring down our 8. How many 6's go into 38? 6 times 6 is 36. 6 times 6, and that's as close as we can get. 36 minus 2, drop down my 7. How many 6's go into 27? 6 times 4 is 24. 6 times 5 is 30. Too big. So 6 times 4 is 24. 3. We drop down our 0. Score! How many 6's go into 30? 5. Awesome. So this ended up just perfectly. Minus 30. And we get to be done. Yay! Alright. So right here, this is just a review of last week, but it's going to aid us in this week. Alright, so now we're moving on to Lesson 21, Decimal Remainders. Let me preface this. That means let me tell you before we start. Let me preface this. It's gonna be I'm teaching you 4 different steps today. Alright, so it's a bit big, but I know you can do it, and you can always look back at this video, and I'm going to send your parents pictures of the lesson too, so then you guys can have those, alright? Okay, so the first thing I'm going to teach you about is option 1. Option 1 for decimal remainder. So we're dividing our decimals still. We're doing the same thing that we've been doing. But for option 1, it says with certain single-digit divisors. So that means our number here, our divisor, with certain single-digit divisors such as 2, 4, 5, or 8. That's a bad 5. 2, 4, 5, or 8. When you have a number with 2, 4, 5, or 8 in the divisor section, most of the time, that can usually always divide out. Yes. Alright, let's see. Let's see. Here's one that they give us. So this is option 1. Alright, so it's going to be dividing 2.3 by 8. Alright, this is a whole number. Do we need to do any moving of decimals? Nope, we don't have to. Alright, how many 8's go into 2? 0. Okay, so now we're here at our decimal. What do we need to do with that decimal? We've hit it. We've got to shoop it up. Alright, now how many 8's go into 23? 8 times 2 is 16. 8 times 3 is 24. So that's too big. 8 times 2 is 16. And that leaves 7. But now am I done? No, I've got to see how, unless they tell you, stop at the 100th place. So this is the 10th place. The next would be the 100th place, then the 1000th place, then the millionth place. They will tell you that. But if they don't tell you, then you just got to keep going, okay? How many 8s go into? Now I can put my imaginary 0. I can put my 0 as many as I need. How many, so let me drop it down for us. How many 8s go into 70? 8 times 5 is 40, 8 times 6 is 48, 8 times 7 is 54, 8 times 8 is 56, 8 times 7 is 56, and 8 times 8 is 64, 8 times 9 is 72, that's too big, so it's got to be 8 times 8, which is 64. Okay, I've got 6 here. Oh, I need another 0. Bring down my next 0. How many 8s go into 60? Let's see here. I said 8 times 7 is 56. 8 times 8 is 64. So 64 is too high. So we have to go 8 times 7 is 56. 4. I can drop my 0. Yay! How many 8s go into 40? 5. Yay! So we're done. Alright. Okay, so that is option 1. Usually, is this every time? No, but with certain single-digit divisors, 2, 4, 5, or 8, right here, it will usually eventually always come out. Alright, so that's option 1. So let me put that over here. Option 1. Let's say divide by 2, 4, 5, 8 comes out. Oh, too bad I can't spell. Comes out. Okay, so that's option 1. Okay, so now we're moving on. What about if a number doesn't have those in it? What about if it's just a regular division problem and it doesn't have that? Option 2, it says, with other single-digit divisors such as 3, 6, 7, or 9. So, all the other ones. Option 2, 3, 6, 7, or, oh man, there you go again, or 9. Okay, it says sometimes you can add all the zeros you want, as many zeros as you can, and you will never arrive at an answer. Without a remainder. So there's going to be some extra. It is with those problems in mind that we address the next 3 options. So option 2, option 3, and option 4. The other things that we'll be learning. Alright, so it says that most of the time in these cases, it'll always tell you to round to the nearest 100th or round to the nearest 1000th. So this is the situation where they'll tell you, okay, go, 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 and then once you hit that spot, once you hit the 100th spot, once you hit the 10th spot, they'll make you round from the next number. Alright, so I'll show you, don't worry. It's a lot of words, but I'll help. Okay, so next we're going to be dividing 7 into 29.6. Alright, here again we have a whole number. We don't have to scoot anything over. Okay, how many 7s go into 2? None. How many 7s go into 29? 7 times 7 is... Nope, that's not it. 7 times 4. Oh, 7 times 4 is 28. 1. Oh, I've got my point. I've hit my point. What do I need to do with it? Shoot it up to the top. Now I can bring down my next number. 6. How many 7s go into 16? 7 times 2 goes into 16, and that makes it 14. I've got 0. Oh, Miss Heather, you're going crazy. All right, now I need to start adding my zeros, right? We'll have to see. Now, if I just kept going, let's just see what happens if Miss Heather keeps going for just a little bit. Okay, I've got my 0 here I can add. 0. This is 2. Because 7 times 3 is 21, so that's not enough. So 14, 6. Add my other 0. I can add as many as I need to. 7's into 60. That's 8. And that's 56. And that's 4. I can add another 0. 40. That's 7 times 6 is 42. So 7 times 5 is 35. Okay, and 5, 0, 57. So obviously, Miss Heather could keep going on for a long time, right? But if the instructions said, round each answer to the nearest hundredth, what would we do? All right. We would look here, and if anybody remembers from our previous lessons, we would have our point, and then this was a tenth, a hundredth, and a thousandth. So anything 1/10, not the tens place. This is the tens place. Not a tens place, tenths place. Tenths place, hundredths place, thousandths place. All right, so if I look right here, here's my point. Here's my point. Here's the tenths place. Here's the tenths place. Here's the hundredths place. Here's the hundredths place. So what they're asking us to do is round the hundredths place. That means they don't want us to keep going forever and ever. You only have to go over 3 places. Why 3? Because, yes, this is the thousandths place. That's not the number that we're stopping on, but we need this number to help us round. Okay? So if we have, and in here, so we're rounding to the hundredths place. My 8 tells me, am I going to go up the score, 5 or more up the score to 4.23? Or is it 4 or less, let it rest with 4.22? Is it going to stay the same? Or is it going to go up? Our number is an 8, so that's 5 or more up the score. So we're rounding up. Our answer in the end would be 4.23. We rounded up 1 place in the hundredths place. All right, so I hope everybody gets that. If you don't worry, just let me know. But that's the main thing, is we're rounding. So at least with option 2. Option 2, you'll need to round. Oh, let me write it over here. Option 2. Okay, divide by 3, 6, 7, or 9. You'll need to round your answer. Okay, you'll need to round your answer. Hope you can see that good. You'll need to round your answer, so then you won't just go on forever and ever and ever and ever and ever. Because that's not a good use of your time, I'll tell you. Okay, so that's option 3. So 3, 6, 7, or 9, you'll need to round your answer, and they will tell you most likely, round to the nearest hundredth, round to the nearest tenth, round to the nearest thousandth. All right? Okay, so that was option 2. Now, let's try option 3. Okay. Option 3 says, another option for divisors such as 3, 6, 7, or 9, so our numbers that we were just looking at, is to look for a pattern. We call decimals with a pattern repeating decimals. When you divide by 3, eventually you will start seeing all 3s. In the quotient that go on and on. When you find a pattern like this, put a line above the repeating part to indicate that it goes on and on. Awesome. Okay, let's try this one. So, 3 divided by 8.5. Okay, how many 3's go into 8? 3, 6, 9. Too far. 2 minus 6. 2. Oh, we've hit our decimal. Shoot it up. And then we drop our 5. How many 3's go into 25? 8. 3 times 8 is 24. 1. I can add as many zeros as I need to. How many 3's go into 10? 3, 6, 9, 12. Too far. Only 3. 3 minus 9. 1. Add as many zeros as I need to. 3 minus 9. 1. 0, 0. 3, 9, 1, 0. So 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Lots of am I ever going to get over this? Is my number ever going to change? No, my number's never going to change. So what did they tell me to do? Alright, they told me if I have a number with all these repeating numbers, they're never going to change. Your answer will just be like this. 2.83 repeating. This little line on top tells me this number is going to repeat forever and it's not going to change. But what about if you put your line all the way over? What does that tell me? That tells me that instead of just the 3 repeating, that it's actually 3, 8, 3, 8, 3, 8. It's all about patterns. So this line tells me my 3 is repeating. So 2.83 repeating. That's what you would say with that. All right. So let's do one more of those. Let's call this one repeated numbers. All right. So the next one, I like my purple pen today. 9 into 4.6. All right. How many 9's go into 4? 0. No 9's go into 4. I've touched my decimal. My decimal shoots up. How many 9's go into 46? 9 times 5 is 45. So 9 times 5 is 45. Alright, got my 1. I can add my zeros whenever I need to. 1. Oh no, we're doing it again. Here we go, lots of 10s. Okay, we're at that problem again. It's just going to keep going. So how do we label it? What do we need to do? You could just call it 0.51 repeating. Only the 1 repeats. So you put your line over the 1. All right. Okay. Let's see. Now this can go, if you see if you see a number, if it doesn't tell you to round to the hundredths place, if it doesn't tell you that, that means that you could have a long answer. You know, let's see here. If we had a mystery number here and numbers here, and say you had all of your work down here and your answer was 6.7932932932932, what would you do with that? You just had to keep going and then you suddenly saw a pattern. Do you think the pattern's going to go away? Patterns don't usually go away. So I look at this and I think, okay, 7932, 932, 932. That means my 932 will be repeating. Would I put it over my 7 or my 6? Nope, I would only put it over the numbers that are repeating. In this example, I'm just telling you that you can have multiple. I'm just telling you can have multiple numbers repeating, okay? So option 3, let's see here, option 3 is repeated. Oh man. Oh, Miss Heather. Alright, repeated numbers. Okay. Alright. Last one. Option 4. We've made it. We're on the last one. Alright. Option 4. Arguably the hardest. Okay, but we're just gonna take it as it comes. Option 4. Let me read it to you. It said, occasionally it is useful to express a decimal answer as a percentage with a fraction in the last place. So not only do you have a decimal, you're doing a fraction and a percentage. Oh, math, why is math so hard? Why do they do this to you? Because they want you to be smart. Alright, so what they're telling you is, let's see, I just have to write it out for you or else we're going to have some trouble. Alright, so this is option 4. Okay, so let me just start with this one. First I have to premise this. It says right here that we are going to be rounding this to the hundredths, but they want it to be a percent, so that means that, yeah, of course it's in the hundredths place, out of percents, out of 100, like 100%. So it's going to be out of 100%, but it says, yeah, it just says that it's useful to express the extra little fraction in there. Let's see here. Because it represents like the oncoming hundredth, like it represents like the rounded part. So let's just try one together. It's a little confusing. It's a little confusing for me too because we wouldn't traditionally use this in our regular math. I think a lot of the other things you might be able to have a real life thing for, but in these kinds of things, 27 and 4/7%, you know, like those would be things that would be like gas or taxes or certain things like that. That's where those appear. So when you're older, you'll have these. Okay, so 7 into 1.93. Alright, so in your directions, I want you to put it in a hundredth with a fraction at the end. So we don't have to go. We only need to go to the thousandth place because we're only rounding it to the hundredth. And then our remainder is just our thousandth place. So don't worry. That was a lot of words for me to say. Let's do it. How many 7s go into 1? 0. Here's our point. Shoots up. How many 7s go into 19? 2. And that is 14. 53. Oh, man. How many 7s go into 53? 7 times 7 is 49. Oh, me. 7 times 7 is 49. Okay, that's 4. 0. I drop it down. 0. How many 7s go into 40? 7 times 5 is 35. Oh, nope. Okay, technically I didn't need to go that far. Man, okay. Wait. Okay. Technically, I didn't need to even go that far. I didn't need to add anything. Okay. Now I confused you more. So sorry. I had to think about what I was doing. Okay. So right now, we're only going to be counting, say, money. We're only, whenever they ask you, because they will ask you to do this. They will ask you, put your answer as a percentage with a fraction. Or put your, that's what they'll ask you. So here, remember percents, we only go, because 100% is 1.00. So when we go into our hundredths place, that means it's out of 100. So it's 0.27, which is the same as 27%. So 0.27, all right? And then they tell us to put a fraction on the end. Now, if we were done with our problem right now, like we are officially done with our problem right now, if we don't want to keep adding zeros because they didn't, because they want us to do this specific thing, option 4, okay? Then it's just a regular division problem. How would we normally put this in our regular division problem? If they'd want a fraction, we'd put 4 sevenths. 0.27 and 4 sevenths. All right? So, like I said, the reason for this, kind of a different thing. Like we don't use this all the time, but we can try it out. Let's do another one. Okay, let's do 6 into 2.75. Okay, how many 6's go into 2? 0. Here's my point. Shoot up. How many 6's go into 27? 6 times 4 is 24. Okay. Now I have a 3. Drop down my 5. How many 6's are in 35? 6 times 5 is 30. Okay. Now if they ask us to put your decimal with a fraction, this is what they're asking. We have our decimal answer. That means they don't want us to keep adding zeros. All right, that means yes, we're scored. Lucky, we're done. You only have to go to the hundredths place. Then the rest is just a remainder. 5, 6, and they might ask you to put it in a percentage form. You just only add a percent sign, that's it. Okay, so I know this was a lot. This was a big lesson. I know you guys can do it though. All right, go slow. Like I said, I'll send the stuff to your parents. So, and if you have questions, just call me. Okay, if I don't get back to you, I'm either in a Zoom meeting or I'm in the restroom or something. So I'll get back to you though, don't worry about it. Try your best. You got this. All right, I love you. Have a good rest of your day. Okay, bye.